So normally, if you were to remember, you're talking about servos motor, right? So often we talk about servo motors, but servo is a servo, motor is a motor, alright? They are two different stuff. So therefore, let's talk about the servo first. Alright, the servo by itself is that you have certain coils. You see, this is actually one coil. Alright, it's a coil of wire coiling around. Alright, that's what I think, because it seems like a coil to me. So the coil itself actually helps to change the rotation. For example, if you have a few coils like this, alright, so you have a few coils. So this is one, this is one, this is set 2, this is set 2. So set 1 has 2 coils. So if you generate a power, this will become a north, this will become a south. Alright, so you actually will turn your motor to this side. Alright, so if let's say you off this one, now you turn on set 2, this one will become north, this is south. So this motor will actually turn to this side. You see? So you'll turn, so you'll actually tilt in different directions. So it's range of 90 degrees because for example, this is the motor, for example. Alright, you can actually go to this place. Alright, it's 90 degrees. Okay, because there's two sets. Alright, there's two sets of coils. One for north, one for south. Alright, so that's just the meaning. So you can vary it if you have more coils. So you have more coils, then you have more variations. Alright, and they are controlled by a stream of pulses at 50 Hz. Alright, so the servos itself is controlled by 50 Hz, and how it works is simply by all the stuff that I've been talking about. And similarly, like your previously the pulse width modulations, your servos is also controlled by a stream of pulses. Alright, so for 1 millisecond it turns to a far left, 1.5 for 0.5 millisecond it turns to center, and then it turns to far right. So what it means is that if I were to show you in terms of a diagram, alright, so over here at first it was like at the right, alright, so for the next 5 millisecond it actually turns here, okay, and then for the next 5 millisecond it actually turns here. You see? So this is actually what they're trying to say lah. Okay? So for every 0.5, so 1 millisecond is far left of minus 45 degrees. So I think it should be this section over here. Alright? Then after that, about 0.5 millisecond later, it will be here. Alright, which is 1.5, which is at the center, 0 degrees. Alright? And after that, at 2 millisecond, it will actually move to here. You see, and so on and so forth. You move all the way I think you get what I mean already. Alright, so same thing, it will actually turn on for a little while, and then it will off. Alright, and then after that it will on again, and then it will off. So 1 to 2 the duration over here, this pulse width is actually 1 to 2 millisecond. Alright, so it's from 1 to 2 millisecond as we have said earlier. Alright, so what we have done just now is what I've shown you over here. This 3 step 1, 1.5 and 2, alright, turns from minus 45 to 45 degrees. Alright, so it turns 90 degrees all along. Alright, so this is what it's trying to say. Okay, so over here it turns 90 degrees. Alright, it waits for a while later, and then it continues to turn another 90 degrees. Alright, so it continues to turn another 90 degrees, and then turn back to here. Alright, I hope you get what I mean. So it kind of rotates. Alright, it kind of rotates. So for example, if you talk about 2.5 to 3 millisecond, then you're gonna shift over to here, and then you're gonna shift over to somewhere here, I think. Yeah, this is 90 degrees also. So this 90 degrees, this new 90 degrees is over here. Alright, so the previous one is actually over here. Alright, so in other words, this one turned 90 degrees. After wait a while, turn another 90 degrees. Wait a while, turn another 90 degrees. So it is pretty slow. Alright, it's a low power. As you can see, the high is actually often quite the length itself is like often quite low. Alright, so it's somewhat like a low power. If it's a high power, then the pulse width is actually like this. Alright, where most of the time it's actually high. Alright, or from here, as you can see, most of the time it's actually low. So you have a low power system. Okay, but nonetheless, I just want to convey that each of this is actually turning 90 degrees, 90 degrees, 90 degrees. Okay, because it's happening so fast, 1 to 2 milliseconds, your eyes cannot capture that the motor itself is actually stopping for such a long period of time. Or your eyes will perceive that the motor is turning, but in fact the motor over here turns, and then over here it slows down, turns again, slows down, turns again. Alright, so this is how it generates the stuff. Okay, unless you can also code your system in terms of a millisecond. Alright, where you talk about over here the pulse 20 instruction is that it's talking about 20 milliseconds. So one instruction is 1 millisecond. Alright, for some reason he say it's 2 calls or two so-called big for the pulse length, the pulse over here. Alright, 1 to 2 milliseconds is still quite slow. Alright, so they want it to be more faster. Then if that's the case, then I think you will require microseconds. Yeah, you will require microseconds, I think. But anyway, I don't think, because he actually didn't go through this at all, so something that for you to take note of. Over here, you know that you're gonna, when you code your Arduino, you're gonna code your Arduino as at this length pulse over here is particular length, and then in delay. So over here, you can write as high, alright, high delay, maybe 2 millisecond, and then low delay 20 millisecond. So high you delay, so over here you delay 2 millisecond, and then over here in low it turns it delay 20 millisecond. Okay, so that's just the meaning of that lah. Okay, so generally how the servos work. Alright, next I'll go into motor. Alright, where we'll talk about stepper motor, where is in other words talking about servo motors also. Alright, so I'll see you in the next video to link the servo to your motor. Alright, so see you there.